Hello, I'm Pawan from Kausalya classes. This is the third lecture of complex number. In lecture 1, I have discussed about introduction of complex number, iota, and in second lecture we discussed about addition, subtraction, multiplication and division of two different complex numbers and their properties. In this lecture, in third lecture, I am going to discuss complex plane. Right, you already aware that in plane we should have two axes to represent a particular point. So in Argand plane or complex plane is just like Cartesian plane, which we have already discussed in class 10th. So let us suppose this is a x-axis, x dash and x, and this is y-axis, that is y and y dash, and this is horizon O. Then we can represent a complex number x plus y iota by a point P where 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 this P can be written as x comma y ordered pair. An ordered pair means x represents the real part of the complex number. Let us suppose this is a complex number, that is p is equal to x plus y iota. So x represents the real part of the complex number, and y represents the imaginary part of the complex number. So in this plane is called complex plane, where we can represent a complex number. So we are having another way to represent a complex number on complex plane, but we will discuss it later on. First we should understand, let us suppose I am having a point, let us suppose a point A, that is minus 3 comma 5. It means this A is nothing but minus 3 plus 5 iota. If I am having a point B, that is minus 2 comma minus 7, that means this B is minus 2 minus 7 iota. Let us suppose I am having a point on y-axis, that is C is equal to 0 comma 5. It means this C is 0 plus 5 iota, and so on. Let us suppose I am having a point D, and that is 5 comma minus 7. It means that D is 5 minus 7 iota. So from A, B, C or D, you can understand that these points represents a complex number in this plane. So this plane is called complex plane or Argand plane, and these complex numbers can be represented in this plane in ordered pair, where the first number is represents a real part of the complex number, and second number represents the imaginary part of the complex number. Our next concept is to represent a complex number in polar form. In polar form, polar form of a complex number. So we are having another technique through which we can represent a complex number. Let us suppose I want to reach at, just wait a second. Let us suppose I want to reach here at this point P. So I should deflect myself from x-axis theta degree in anti-clockwise direction and walk from origin at r distance, will reach at P. If I want to uh, reach somewhere here at Q, then I should walk r1 distance from origin to this point, and deflect myself from positive x-axis to theta 1 angle. So with the help of theta and r, we can reach at any point in this plane. So this P can be represented by r comma theta, and this Q can be represented by r1 comma theta 1. So in trigonometry we have already discussed that, let us suppose this is a right angle triangle. Let us suppose this is a right angle triangle and this is 90°, then this will be definitely the base. And as we discussed in earlier concept, this is x. This P point can be represented by x comma y ordered pair. So this x is nothing but r cos theta. Those who are having confusion, they can recall their 10th class trigonometry, where they have already gone through the idea that if this is a theta, this will be the P and this will be the B, and if this is H, this B can be written as H cos theta and this P can be written as H sin theta. This is what I am doing here. So x is equal to r cos theta and y, this is y, is equal to r sin theta. So if I want to get the value of r from the, let us suppose I am having a complex number P that is equal to x comma y iota. If this is the complex number, then P can be represented in complex plane as P x comma y. And if I want to obtain this r, what should I write? I should write x square, that is r cos theta to the whole square, and y square, that is r sin theta whole square. So if I'm gonna add x square plus y square, I will get r square cos square theta plus r square sin square theta, and that will give me r square sin square theta plus cos square theta, and sin square theta cos square theta will become 1, and r will be equal to under root x square plus y square. So in polar form I have to write r and theta. The complex numbers should be in form of r and theta. So I just got the idea for r and how we can obtain r from the given complex number. It's very easy. If a complex number is given, it is very easy for us to obtain this r. Now let us suppose this P r comma theta is called the polar coordinate. So you should keep in your mind that P r comma theta is called polar coordinate. Polar coordinates of P. Okay. Now and theta, and this theta is called argument. Another name is amplitude of Z. Means this theta is amplitude or argument of a complex number, and this theta may be less than 90°, 90°, more than 90°, 180°, more than 180°, 270°, or more than 270°, or 360°. So this theta may be 0 or maybe 360°. So this theta will be between 0 to 360. So this will give me the complex number in either the first quadrant or second quadrant or third quadrant or fourth quadrant. So let's discuss the working rules for converting working rules for converting z is equal to x plus y iota to polar form. Now let's z is equal to x plus y iota is given. So this x plus y iota, that is z, can be written as r cos theta, as x is equal to r cos theta plus r sin theta iota, as we have discussed that y is equal to r sin theta. So we should find, for every case we should find r and theta may be in first quadrant, second quadrant, third quadrant or fourth quadrant depending upon the given value. If the real part of a complex, let us suppose theta will belong in first quadrant only when the value of complex number where the real part and imaginary part both are positive. Theta will be in second quadrant only if real part of the complex number is negative and imaginary part of the complex number is positive. Theta will be in third quadrant only if the real part of the complex number is negative and imaginary part of the complex number is also negative. Theta will belongs to the fourth quadrant, and for this case the complex number will have positive real part but negative imaginary part. So if theta will be in first quadrant, it means the real part and the imaginary part of a complex number both will be positive, and if theta is in second quadrant, it means the real part is negative and imaginary part will be positive. If theta is in third quadrant, it means the real part is negative and imaginary part is also negative. If theta is in fourth quadrant, real part is positive but imaginary part is negative. So it's very easy to find it out theta for the different cases. So our target is to find out the value of r, which we have already discussed. R is equal to nothing but the mod of z, x square plus y square. We already gone through the idea of mod of a complex number. Mod of a complex number is equal to square root of the square of real part plus square of imaginary part, and theta we can obtain by different technique. See, as we know that r sin theta is y and r cos theta is x. If we are going to divide both, we'll get tan theta, that is equal to y upon x. So from this idea we will get theta, that is theta is equal to tan inverse y upon x. This is the one technique through which you can get the theta. But what if the z is purely real? Now we are going to discuss the different cases for theta. So here we are going to find out theta for different cases. Case number 1. First case, when z is purely real, that means imaginary part of z will be 0. So in first case the complex number will lie somewhere here or somewhere here. So if this is the complex number z1 and if this is the complex number z2, so for in first case there is two possibility. Case 1, the real part of z is positive, means lie on positive x-axis. That means lies in positive x-axis, then theta will be 0. Case 2, real part of z is negative, means that is the case of z2, and this is the case for z1. So this complex number lies in negative x-axis and theta will be pi. This is the case first where z is purely real. Now case 2. In case 2, when z is purely imaginary, that means the real part of z will be 0. So here also there will be two cases, z1 and z2. For z1, if the real part or if the imaginary part of z is positive, then the theta will be pi by 2, means 90. And if, as you already know, if we are calculating theta in anti-clockwise direction, we will count theta as a positive. If we are going to take the angle in clockwise direction, the theta will be negative. So if imaginary part of z is negative, then theta will be minus pi by 2, right? So once we will do the problems, we'll understand the concept what we are discussing right now. So we have already discussed the two cases. Case number 1, when the complex number is purely imaginary, and the first case was purely real. Case number 3. Case number 3, when complex number is having both real part as well as imaginary part. So the complex number may lie in any one of the four coordinate. So if the real part is positive and imaginary part is also positive, the theta will be between 0 to pi by 2. If real part is negative and imaginary part is positive, then theta will lie in second quadrant, and we should write the theta will be pi minus alpha. It's better to write alpha instead of theta because theta may be any value. Let us suppose we should consider a angle alpha. We should consider a angle alpha in such a way that the alpha is always between 0 to pi by 2. Okay, so for the first quadrant, the theta is equal to alpha itself, and for second quadrant, the theta will be equal to pi minus alpha. If the real part is negative and imaginary part is also negative, means theta will be alpha minus pi, because see, pi is 180 degree and alpha is between 0 to 90 degree. So if we are going to subtract pi, the value will be negative and less than pi by 2. So it will be in third quadrant. So for first quadrant, theta is equal to alpha. For second quadrant, theta is equal to pi minus alpha. For third quadrant, theta is equal to alpha minus pi. And for fourth quadrant, the real part is also positive but imaginary part is negative. In this case, theta is equal to minus alpha. So So this is the way through which you can understand. Now represent some complex number in polar form. For example, z is equal to 3. So z is equal to 3 can be written as z is equal to 3 plus 0 iota. So x is 3 and y is 0. So r is equal to under root 3 square plus 0 square. So the answer will be 3 itself. The answer will be 3 itself. And the polar form of complex number is nothing but r cos theta plus r sin theta iota. So we got the value of r, right? Now we should find out the value of theta. So you can clearly see here it's a purely real complex number. It's purely real number. So the theta will lie either on positive x-axis or negative x-axis, right? So here you can write r is 3 and x is equal to r cos theta, and r is 3 and x is 3. So cos theta will be 1, and 1 means cos will be 0. So you got that theta is equal to 0. So here you can write z is equal to 3 common cos 0 plus sine 0 iota. This will be the polar form of the complex number. So you can solve so many problems related to this concept, like how to represent z is equal to minus 3 in polar form. So this is very easy. You can write z is equal to minus 3 plus 0 iota. From real part is negative and imaginary part is 0, means this complex number will lie on x-axis and in negative x-axis, minus x-axis. So theta will be pi, and r is equal to under root minus 3 square plus 0 square. So r is 3. So the complex number can be written in a polar form: 3 bracket cos pi plus sine pi iota. So this is the way through which you can represent the complex number in polar form. So you can solve so many problems. The problems related to the polar concept is very easy. Let us suppose take some another example. For example, z is equal to minus 1 plus under root 3 iota. So here the real part is negative and imaginary part is positive. It means this complex number will lie in second quadrant. Second quadrant means theta will be equal to pi minus alpha. So let's check it out, the alpha. So minus 1 is equal to r cos theta, and under root 3 is equal to r sin theta. So once we are going to divide, let us suppose this is equation 1 and this is equation 2. So divide equation 2 with equation 1, you will get r sin theta upon r cos theta is equal to under root 3 upon minus 1, right? So this will give you tan theta, that is equal to minus under root 3. So you can write tan theta is equal to minus tan pi by tan 60, means pi by 3. So you will get tan pi by 3. So here the the, the value of theta is pi by 3. Okay, but as we know that the value belongs to the second quadrant, so the theta will be is equal to pi minus pi by 3. So this will be equal to 2 pi by 3. So theta will be 2 pi by 3 and r is equal to under root minus 1 whole square plus under root 3 square. So this will become 3, this will become 1, 4, so the r will be 2. So now we got the value of r and theta. It is easy for us to represent complex number in polar form. So that is z, that is z is equal to 2 cos 2 pi by 3 plus 2 sine 2 pi by 3 iota. So this is the polar form of this complex number, and we discussed few problem. For more problem you can give me the test, or you can write on comment box if you want a question bank related to the polar form of the complex number. Good luck. The next topic we will take in next lecture. Thank you.